Today, class, we're going to learn about indirect proof. Sherlock Holmes observed that when you have eliminated the impossible, whatever remains, however improbable, must be the truth. Indirect proof is the mathematical counterpart of Sherlock Holmes' observation. So far, you have written proofs using direct reasoning. You begin with a true hypothesis and build a logical argument to show that a conclusion was true. In an indirect proof, you begin by assuming that the conclusion is false. Then you show that the assumption leads to a contradiction. This type of proof is also known as proof by contradiction. So there are 3 steps in an indirect proof. The first step is to assume the negation of the conclusion, which is your proof statement, is true. Remember, negation, all you need to do is add or take away a not. Step 2, you reason logically to show that the assumption leads to a contradiction. Of a known fact, theorem, definition, postulate, given, or etc. And then you conclude that the assumption is false and therefore your proof is true. So before we do an indirect proof, let's review some examples of negation. Example 1 says, state the negation of the following. And remember, negation means all you're doing is adding or taking away a not. So example 1, the measure of angle 1 equals the measure of angle 2. So negation is the measure of angle 1 is not equal to the measure of angle 2. Number 2, segment AB is not perpendicular to segment CD. So negation will be segment AB is perpendicular to segment CD. Number 3, letter C. Segment AB does not intersect segment CD. The negation would be segment AB does intersect segment CD. Okay, example 2. Do the following form contradictions? Segment AB is parallel to segment CD, and segment AB is perpendicular to segment CD. Yes, that is a contradiction. Because lines cannot be parallel and perpendicular at the same time. Let's draw you a picture to help you better visualize this. Okay, so here's a picture of AB parallel to CD. And here's a picture of AB perpendicular to CD. notice it cannot happen at the same time. B says, in triangle ABC, the measure of angle A equals the measure of angle B, and triangle ABC is scalene. Is that a contradiction? Yes, that is a contradiction. Because a scalene triangle has three congruent sides, three different sides. Let's draw a picture of a scalene triangle. So triangle A, B, C. So if all three sides are different, that means all three angles are different. Whereas a triangle with angle A equal to angle B we learned the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite them are congruent. So notice in the picture, this is a contradiction. What about C? Triangle ABC is equilateral and triangle ABC is equiangular. Is that a contradiction? No, because an equiangular triangle is also an equilateral triangle. Let's show you a picture of that. An equilateral triangle is also an equiangular triangle. Okay, what about D? Triangle ABC is a right triangle and the measure of angle B is 100 degrees. Yes, that is a contradiction. Let's draw a picture to show you. So here's triangle ABC with a right angle. And let's draw a triangle ABC with a angle that's 100 degrees. So you cannot be in a right triangle and obtuse triangle at the same time. Now example 3 asks the question, write the first step of an indirect proof. Suppose you want to write an indirect proof of each statement. As the first step of the proof, what would you assume? Remember, in our notes, you assume the negation of your conclusion, which is your proof statement is true. So in example A, an integer n is divisible by 5. The negation would be assume an integer n is not divisible by 5. And B states, you do not have soccer practice today. The negation would be, assume you do have soccer practice today. Now that we know how to identify the negation, which is the first step in an indirect proof, now we're going to figure out how to find contradictions, which is the second step in an indirect proof. Number 4 states, identify contradictions. What statements contradict each other? 1. Segment FG is parallel to segment KL. 2. Segment FG is congruent to segment KL. Or 3. Segment FG is perpendicular to segment KL. The two statements that contradict each other are statements 1 and 3, because you cannot have lines that are parallel and perpendicular at the same time. So let's draw a picture of what we mean by this contradiction. So we have segment FG and segment KL. They're parallel. And then we have segment FG and segment KL. They're perpendicular. Notice you cannot have these at the same time. So example 5 states, write the following as a conditional statement and then write the contrapositive. Recall that contrapositive means you reverse the sentence and you add a not. So the given is angle A is not complementary to angle B. You have to prove that angle C is not a right angle. So a conditional means you can write it in the if-then form. So you would say, if angle C is not complementary to angle B, then angle C is not a right angle. So the contrapositive, we will reverse that and add a not. So it will read, if angle C is a right angle, then angle C is complementary to angle B. Then angle A is complementary to angle B, excuse me. And recall from Unit 3, a conditional and its converse are logically equivalent. That means if the conditional is true, then the converse is true. And if the converse is false, then the conditional is false. And the symbol should be a conditional and the contrapositive are logically equivalent. And the converse and inverse are logically equivalent. So if the converse is true, then the inverse is true. If the converse is false, then the inverse is false. So let's see if we can identify the conditional and the contrapositive and see how it can help us in writing an indirect proof. So example 6, writing a proof by contradiction. You are given that segment AB is not congruent to segment BC. You got to prove that angle A is not congruent to angle C. So let's first identify the conditional, rewriting the statement using if and then. So if segment AB is not congruent to segment BC, then angle A is not congruent to angle C. So with the contrapositive, we will reverse that and add a not. So it would read, if angle A is congruent to angle C, then segment AB is not congruent to segment BC. Notice that can help us in creating our indirect proof. Remember, an indirect proof has 3 steps. So the first step is you assume the negation of your proof statement. So your proof states that angle A is not congruent to angle C. So the negation of that will be assume angle A is congruent to angle C. So let's put arc marks on the picture for angle A and angle C. So if that's the case, then segment AB is congruent to segment BC. So let's put tick marks on the picture because of the converse of the isosceles triangle theorem. Recall that the converse of the isosceles triangle theorem states if the angles of a triangle are congruent, then the sides opposite them are congruent. But this contradicts the given that segment AB is not congruent to segment BC. Therefore, our assumption is false and our proof that angle A is not congruent to angle C is true. Notice how writing our contrapositive helps us to write an indirect proof. Let's do the same thing for example number 7. It says you are given that angle A is not congruent to angle 3. You have to prove that K is not parallel to L. So let's first write our conditional, rewriting the sentence using if and then. So it will read, if angle 1 is not congruent to angle 3, then K is not parallel to L. Now the contrapositive will be you reverse that and add a not. So it will be if So if K is not parallel to L, then angle 1 is not congruent to angle 3. Notice how the contrapositive will help us in writing our indirect proof. So the first thing we need to do is assume the negation of your proof. So your proof states that K is parallel to L. So the negation of that will be, the proof states that K is not parallel to the L. So the negation of that will be K is parallel to L. So then we know that angle 1 must be congruent to angle 3. So I'm going to put arc marks on angle 1 and 3. And we know this because if the lines are parallel, then corresponding angles are congruent. But this contradicts the given that angle 1 is not congruent to angle 3. Therefore, our assumption is false and our proof that K is not parallel to L is true. Again, notice how writing the contrapositive helps us to write an indirect proof. And then our last example, writing an indirect proof. It states, you are given that triangle ABC is scaling. You have to prove that angle A, angle B, and angle C are all different measures. So let's first draw a picture of a triangle. So we have to assume the negation of our proof. So we have to assume that two angles of triangle ABC have the same measure. So I'm going to assume that measure of angle A equals the measure of angle B. So I'm going to put arc marks on A and arc marks on B. But by the converse of the isosceles triangle theorem, the sides opposite angle A and angle B are congruent. So that means segment AC and segment BC are congruent. This contradicts the given that triangle ABC is scaling. Because notice we now have a picture of an isosceles triangle. Therefore, our assumption must be false and our proof, angle A, angle B, and angle C have all different measures is true. Okay, so play this video over and over again to help you do your homework.